Good morning. We're just going to give a couple of minutes to get started. I can see people coming into the chat. Thanks for joining us. Feel free to tell us where you're dialing in from this morning. I know we often have a few people from the Northern Hemisphere, and Vignesh and I are both down in the south, in New Zealand, and well, I'm in Sydney today actually. But yeah, tell us where you're dialing in from if you want to join in, and we'll just give it another couple of minutes to get started. All right, I might start introducing Vignesh because we've got quite a lot to get through this morning. But I'd love to just first begin by acknowledging the traditional owners of the land upon which we meet. So we pay our respects to the elders past, present and emerging, and we acknowledge their spiritual connection to country. As some of you know, my name is Malia. I'm part of the Blackbird team, and today we're fortunate to have Vignesh Kumar joining us for this session of Giants Weekly. So today, Vignesh is a technology investor and a partner at GD1. But before he was an investor, he actually spent over a decade in global technology design, manufacturing and operations strategy in roles across the US, East Asia and Asia Pacific. Before returning to New Zealand in mid-2018, Vignesh was one of the lead global supply managers for Apple, where he was directly responsible for the management of both the design transfer process from product design through to mass production, and the enclosure hardware supply chain for the portables line of product. Vignesh also led the front-end engineering strategy by working closely with design teams to engineer new enclosure technologies and startups that aligned with Apple's product vision, which spearheaded new commercial strategies to license, acquire, scale, and integrate these technologies into Apple's development pipelines and products. So today, Vignesh will draw on this wealth of experience to teach us about scaling hardware. We'll explore what's important, what it means to scale, design for manufacturing, what breaks at scale, and how to build with a commoditized mindset versus a bespoke mindset. So as usual, we'll launch straight into this presentation, and you can send any questions or comments that you have into the Zoom Q&A, not the chat, the QA function, and we'll leave around 10 minutes at the end for these to be answered. Over to you, Vignesh.
Awesome. Thank you, Amelia, and thank you for the generous and kind words. Let me just quickly share my screen. Oh, 1 second. Okay. Awesome. So I guess just to quickly preface everything we're going to talk about today, scaling hardware products is obviously the theme of the talk, but I also just want to say that the talk today will be a bit more of generalized nature, right? I think given the wide range of skills and backgrounds that people might have on this call, I'm a little bit hesitant to dive too deeply into the engineering minutiae for everyone. So feel free, at the end of the talk to kind of reach out, ask more clarifying questions. More than happy to take those conversations offline. So in terms of the agenda today, as Melia said, we're looking at hardware scaling. And for me, hardware scaling is, over the time I've been in the ecosystem, broken down into kind of several core areas. And the first is kind of the importance of why it matters, especially in a startup context, right? And then it's more of the qualitative aspects. So design for manufacturing, design mindset, and company culture. Those things do have a bit more of a kind of programmatic feel to them. There are processes and methods that you employ, but again, for the purposes of the conversation today, I'll try and keep them a bit more kind of high level, a bit more qualitative in nature. So just quickly first, my background. So the generous intro Amelia gave me definitely hypes me up a bit more than what I've done. But yeah, look, my career has been in product design and engineering, and that's through and through. I've not done anything different from that. I was originally born and raised in Papua New Guinea, the Pacific Islands, above Australia. Moved to New Zealand, and then in New Zealand went through the engineering pathway, becoming a biomedical engineer. For me, the career highlights have been working in Silicon Valley at Apple and going to the consumer side of electronics, taking products from literally 0 units to tens of millions of units per month production. And you can imagine what kind of experience that must be like. And yeah, I'll be the first to admit it's definitely been a harrowing experience at the worst of times and a thrilling experience at the best of times at a place like Apple. Another kind of highlight for me is also product design at Fisher & Paykel Healthcare. So in New Zealand, Fisher & Paykel Healthcare is the standalone medical device business, not the white goods business that some of you might be familiar with in Australia. And so the healthcare business is rip-roaring, growing quite dramatically, I think valued at $20–30 billion now. And in that org, I worked in the neonatal infant resus team, so designing products to resuscitate premature babies. Another highlight of mine. More recently in the ecosystem in New Zealand, in the tech ecosystem with startups, I'm a startup investor and director across a number of digital health, software, hardware combo startups. And I also sit on investment committees for science commercialization coming out of the universities, trying to nudge people to not pursue an academic career, but trying their hand at startup commercialization. And wrapping up all of these experiences, I'm also a venture partner for a New Zealand VC fund, and also a founder of my own digital health startup, Journey Health. So jumping into the agenda for today, scaling and why it matters, right? I think this is just the context and level setting for what I mean by hardware scaling. And I'll start off by talking about it in the lens of hardware scaling in general, and then try and tie it back to the hardware startups and how you can kind of take on those best practices. So first, some context and level setting, right? So when you have a product, take for example, the iPhone 12 Pro that just recently released, it really is the kind of confluence of two things, right? Software and hardware. And software in the startup ecosystem, everyone's probably well aware that it's fast converging to a really efficient input-output driven design thesis. The deployment and development infrastructure is becoming really rapidly scalable from day one. And that's allowing you to kind of build world-beating apps, experiences from your home, from your bedroom. But then when you are augmenting this software experience with hardware, it changes the nature of your product, the development timelines, and the complexity, right? And again, to caveat everything, this is a generalized product experience where in the iPhone's case, the hardware underpins the software experience, right? And it adds to it with some functionality that overall makes still the software shine. So the hardware adds aspects of complexity around industrial design, product design, and manufacturing design. And unlike the software side of things, this infrastructure has lead times, has learning curves, and cannot instantly launch at scale. So while you may be able to hack together an MVP of some hardware product in your garage or in your workshop, getting to something that is repeatable, reliable, and also sellable in the truest sense of the word is quite difficult and hard and takes a bit of timeline to it. So that's the reason why scaling matters, especially from a startup perspective. And so when I talk about what scaling is, the core thing is look at the top right corner: volume, cycle time, yield, and cost. And so that's really the core takeaways here. When someone's talking about scaling hardware, scaling engineering, it really distills into these kind of 4 core metrics. And those 4 core metrics, when you break them down, right? Volume, make more of your product. That's what you're wanting to do. Cycle time, you are wanting to effectively decrease the time it takes to make 1 unit of your product and in doing so, increase the throughput of your ability, right? You want to be making as many as possible in the same quantity of time. So 1 hour, you want to be able to go from making 2 widgets to 10 widgets. So that's the cycle time gain there. And then yield. When we talk about yield, yield is really, in a simplified sense, the failure and pass rate of your product when it's kind of going through the engineering production process. And so ultimately, when you're scaling, you want to be climbing up what we call a yield curve and improving your yield. And obviously, the last one there is cost, right? I think whenever you're scaling hardware product, creating a combined software hardware product, you don't want the hardware to be something that costs so much that your whole process is not economically viable, especially as you try to scale the business. So you want it to be something that augments your ability to make money, right? And so in the modern day with startups, we're seeing larger startups, admittedly ones that have gone public, use hardware as a sort of customer acquisition cost to lock in customers. And that's how they start to create their money too, because the hardware has a good marginal cost on it and doesn't cost them too much to make. So when you peel back the layers of the onion, you kind of go, why does it matter then, right? Why does scaling matter? So first thing is kind of looking at the graph. I admit it's a bit busy, but when you look at the graph, there's kind of 3 ways I like to break it up. What I call pre-product market fit, the product market fit zone, and then post-product market fit. And essentially what you're learning with hardware and in a startup's perspective is that until you get to product market fit, your R&D team who are doing the hardware design, who are doing the hardware engineering, are kind of inextricably tied to the sales process as well, where they're soliciting the feedback, constantly adjusting the design features, and you don't really have a stable product. It's constantly in flux. And so the consequence of this is that you aren't able to make as much product as you'd like. And secondly, you're left kind of servicing from an internal operations perspective, products that are slightly variable across each unit. And so there's high maintenance cost, high repair cost, and it really, really drags down your ability to make money and grow as a startup. So that's kind of the thing with hardware startups is you need to understand that there's a bit of a conceit here. Until you kind of get to the product market fit zone, your R&D will be inextricably tied to the sales and execution. Once you get past that point, the R&D process decouples from execution and sales. And so that's really saying that your R&D is able to actually just keep focusing on product supremacy, company supremacy, and not get stuck into the minutia of iterating on product design. So that's what we mean. And so kind of coming back to why it matters, firstly, grow better quality revenue streams, because as you move up and scale, you're able to actually not allocate money to things like maintenance, repair, servicing the bespoke nature of design and changing it. And then also with your R&D engineering team, you allow them to decouple and move on to the next iteration of the product and help you kind of grow your technology supremacy there. Oops. Sorry, let's go back a second. So the things that break when scaling, right? And this is something that I can confidently say across my 13 years in engineering. Regardless of the best laid out plans, of how well optimized they are, things that can go wrong do go wrong, right? And this happens when you scale. So when you go from 0 to 10, when you go from 10 to 100, when you go from 100 to 1,000, things will always break. Things get magnified. Issues which you've not foreseen get amplified and they break. And so for those of you who are already dealing with hardware startups, you'll probably be aware of Murphy's Law. And it's kind of anecdotal and colloquial evidence that things just break because they can. And so from my experience working across startups to larger companies, the things that I've seen break include the kind of core areas there, which is engineering design that is additive and reactive. And when I say additive and reactive, it's design which is kind of just bolted on to solve a problem that's popped up. And so you're fixing the symptom of the problem, and not necessarily the problem of itself. And you end up in this kind of whack-a-mole situation, especially when you're scaling hardware. And you can imagine when you're trying to sell thousands of widgets or whatever and get your product into market, if you're having to whack-a-mole across thousands of tens of thousands of things, that's not a sustainable experience, and you'll end up failing on your ability to deliver. Similarly, the engineering processes, right, that are kind of layered throughout your hardware scaling. In my experience with all of the operation strategy of things, you need to really have a concerted effort in planning out how you engineer, how you mass produce, how you work with your partners, internal and external, and that you avoid unnecessary kind of loop backs and touch points, which introduce time, complexity, and dialogue, which can hamper the process. And then artisanal type componentry, right? And this is something that I've seen with startups, and it's funny because you only learn to not do this when you've gone through having done it. And so with the artisanal type componentry, startups in particular love the fact that you can add carbon fiber struts to something. You can add some sort of specific bespoke machining. You want to add in this high value ASIC or system on a chipboard. And all of these things are artisanal in nature, right? And so when it takes time for someone to apply them to the product in terms of a manufacturing sense or an integration sense, when it takes time to engineer that component and get it shipped to you, that's artisanal and it's not really helpful. And when you try and scale your product, it will break, guaranteed. So you need to really understand that there's a trade-off between kind of that bespoke artisanal work and commoditized off-the-shelf componentry that allows you to just move swiftly. And that's something I'll touch on later. And then lastly, it's kind of the continuation of the artisanal stuff, which is the far-flung locations and lead times for materials. So another thing I've seen with startups and even larger companies is that they like sourcing materials from all parts of the world without a sense of understanding how does it integrate into my supply chain? How does it come to New Zealand, for example? So we're at the bottom of the world, and if we have to source something from the US, it goes to Singapore to be integrated, and then it has to backtrack to Japan for another component, and then it has to come back down to New Zealand. You're really inefficiently planning your engineering process, and that's not scalable, right? So if your widget project is to kind of catch on fire and start becoming a hot seller, you'll end up with this catch-22 of increasing sales coming in, increasing liabilities on your books, and an inability to sell product actually and deliver. And then lastly, but most importantly, is team morale, right? I think all of the above things, they kind of distill into team morale. When things start breaking, especially with hardware, you'll notice that teams will start losing confidence. They'll start losing a lot of self-belief, and then they will also start just having periods of what I like to call just poor mental wellness, right? And that's detriment to your startup. And in this day and age, especially with COVID and whatnot, you don't need to be layering on the effects of COVID's mental wellness effects with hardware delivery mental wellness effects. And it's just kind of this really disastrous thing. So you need to be cognizant of team morale and ensuring that you have robust processes in place to manage it. So having talked about design scaling and what it is and what breaks, I want to now step through kind of the qualitative aspects of design for manufacturing, right? And so design for manufacturing in the technical sense of the word is really a programmatic set of steps and processes that allows you to carry a design from kind of inception all the way to manufacturing. But again, for the purposes of this talk, I'll try and keep it a bit more top level, a bit more qualitative. An aspect of design for manufacturing is effective design transfer. And so design transfer here in the truest sense of the word is being able to just bridge across your different functions, right? Sales, engineering, and execution. And so when I say engineering, it's the R&D team coming up with stuff. When I say execution, it's the folks in the factory or whatnot when you're dealing with hardware. You don't want people operating in silos. You want them to be sharing information across the spectrum. And having worked with startups again, and larger companies in the ecosystem, you see that the best ones have realized the kind of purpose of effective design transfer across those orgs. Otherwise, you're just kind of fighting against the wind, right? And then with design transfer as well, there's an aspect of having someone on the team who knows the boundaries of what is technically capable, right? And what you could reasonably achieve, and then what you could try and what I call blunt force innovate through. And so this is kind of at odds with the startup thematic, which is people are encouraged to kind of aim for the aspirational, do the impossible and break the impossible. But then when you are delivering hardware, you're bound by this pesky thing called physics. And so you need to be able to also recognize that there are some limits, especially to the engineering process. And if you're leading it, you have to have the ability to kind of push back on this sort of blue sky thinking within reason. And at the same time, assuming that resources are kind of an infinite, non-constrained issue. So let's say you're a well-capitalized startup, Blackbird's given you 10 million, assuming money and time aren't a problem, you can reasonably blunt force innovate through problems, right? And so that's what companies like Apple do, where they just have essentially a blank checkbook on the R&D side to just blunt force innovate through physics barriers on the engineering side. And so that's kind of the aspect of design transfer, is having someone who recognizes the kind of stakes in the ground here. And then also with design transfer, right, following on from that kind of stakes in the ground, is being wary of scope creep. And scope creep is not just a software issue, it's a hardware issue. And as I alluded to in earlier slides, scope creep creeps in because if you're selling the future versus selling the reality, you're trying to get your startup to that next point. And so it's easy for it to bleed in. But again, having the leadership confidence to be like, hey, scope creep isn't helpful for us in delivering this product, and trusting your gut feeling on execution and saying, hey, maybe no is the answer to that feature. And then this also is the kind of the culmination of all the previous points, right? The us versus them problem. So I mentioned the sales, engineering, execution teams. You don't want your teams operating in silos. The worst thing you could do is to allow them to kind of be in their echo chambers and create this kind of fiefdom of us versus them. That's not conducive to anything. And also, you want to set goals that span across these organizations and are not just tailored to the specific execution teams or the R&D teams. You want people to feel invested in the goal across the organization. And then kind of tying all of these things together is really design mindset, right? And design mindset, I'll dive a bit deeper into here. It kind of focuses on two main areas for me. The first of which is the purpose of the hardware innovation, right? And I always, whenever we're working on hardware now, especially on some of our investee companies, I try and force kind of a difficult set of questions on them, which is this an enabling technology, right? And enabling technologies, for those of you who are aware, are things that shift the needle or the dial in society, create great innovation and efficiencies. And it's a little bit of a lofty question, and I know the answer is always going to be a no, but it forces people to kind of take a bit of humble pie, right? And realize that, yeah, maybe this isn't as earth-shattering as I thought it was. So that's the purpose of it. So is this enabling technology kind of helps you level set people back to the reality of what's possible. And then the whole first principles and bottoms up approach. So whenever I'm working with hardware startups, a lot of people like to talk about the first principles and bottoms up approach to coming up with a product and how I found a problem and a need. And that's great. I definitely think first principles and bottoms up approach is a very intuitive, process-driven way to think about problems, but it also in some cases over-engineers a problem. And so I would kind of hesitate to recommend it as a wholesale tool when you're working on hardware problems, but it can be a useful thing. And so that's why I've mentioned it. And as an example of the kind of first principles, bottoms up approach, you look at the Tesla business plan, right? And this is something that a lot of folks will have some experience with, who are investing in Tesla and other EV stocks in the market. You will see that this is the plan that Elon Musk came up with, supposedly when he was coming up with Tesla in the early 2000s. And so it's sort of this first principles approach of, I'm going to build X to build Y, those revenues fund Z, and I keep moving down the funnel. And then this comes back to something I mentioned earlier, which is the commoditized versus bespoke design mindset. You don't necessarily need to build things from scratch. You don't necessarily need to engineer everything from the bottom up. And you can definitely get things off the shelf and try and get to your minimum viable product in a demonstratable fashion, right? And then the second aspect of thinking of commoditized versus bespoke, when you have a clear purpose of what your engineering product is going to be, if it's commoditized, you know that, hey, maybe I'm just going to engage with a contract manufacturer where I do the design, I send it to them, and I buy the finished good. And there's nothing wrong in that, right? I think a lot of hardware startups kind of shoot themselves in the foot by having pre-seed and seed pitches that talk about building factories. And I'll tell you right now, as someone that's helped build a factory several times, it is incredibly hard, even for companies like Apple. So you want to realize the limitations of your ability and say, hey, am I going to have somewhat of a bespoke engineering process, R&D process for my hardware startup? If not, I'll go on the contract manufacturer route. There's nothing wrong in that. And I think it shows a level of maturity and sophistication, especially with investors who realize that you can at least see past the glitz and glamour of building your own capability. And then the last bit of the commoditized versus bespoke argument is really, are you feature rich or feature light with your hardware? Especially around its core use, right? And this comes back to the forcing functions that I kind of push on hardware startups I work with. Are you building another phone? Okay, you're building another phone. Are you feature rich or feature light here with hardware? What do you need to be? And people might say that, hey, I'm going to be competing with the iPhone or Samsung or whatever, and I need to be feature rich. And so that immediately tells me that this is going to be an expensive proposition, right? And so all those sorts of forcing functions help you understand, are you going to be commoditized or bespoke? And when you're feature rich, it lends heavily towards the bespoke nature of stuff. When you're going feature light, it lends heavily towards the commoditized aspect of engineering. And then this is kind of the final part of the design mindset, right? Which is the selling the future versus selling the reality. So I'm always encouraging people who work in hardware startups to kind of realize the conceit of the big vision picture versus the practical realities of physics and engineering. What can you actually make? And if your sales team and CEO and founder are pitching something else, is that in tune with the reality of what is practically possible? And you can't allow that distance between them to grow to some uncoverable gap, irrecoverable gap, just because as a startup you'll fail them. So it's really important that you have some reality in there. Be optimistic by all means, but have some reality tied into there, right? And as I said earlier on one of the slides, this has a big impact on team morale. So you don't underestimate that by selling the future and not really selling reality, you're constantly subjugating your engineering team to this moving bar that keeps getting away from them, and you're really just setting them up for failure. And then finally, for me, with all of the scaling hardware stuff, it's just hygiene factors now, which is good company culture, right? And so these are just kind of things that I've noticed, and I'd like to reiterate to people watching to understand what matters, right? So practice open and honest communication. And so the worst thing you can do, especially when you're building hardware, is to kind of layer your responses in sort of aspirational what ifs, half statements, half truths. And I've noticed with hardware startups, people feel that they have to kind of stretch the fabric of truth a little bit to keep in lockstep with the sales team, with the founder. No, just practice open and honest communication. It helps to have the clear understanding of where you are. Celebrate all wins, not just sales or consumer facing actions. This is something I see all too often, right? Which is the sales team, the exec team, they celebrate the sales ability to sell the future, to sell the vision. But the hardware team and execution team are never really able to celebrate their modest successes. And so a modest success is being able to go from making 2 widgets, 3 widgets to suddenly 6 widgets, right? So being able to double your ability to output a product should equally be celebrated, to keep that team morale constant. And then this is kind of the flip side of all of that, which is the empathy, right? You need to be able to recognize and feel the emotions and reasons for why people are feeling the way they do, especially if you end up with this selling the future versus selling reality gulf between your sales and engineering teams. Don't underestimate the power of empathy, right? People aren't looking for sympathy, they're looking for empathy. So you need to be able to resonate with why they feel that way, and not necessarily just give your kind of sympathies for, oh, yep, you do better next ramp or something like that. So you need to understand why they're feeling that way so you can truly unplug the design issues on hardware. And then this is just, again, a hygiene factor for all startups. High stress situations can occur, and they frequently do in startups, right? This is when you are incepted with the notion of changing the world, breaking things, making things. High stress situations occur, but it's important that you have leadership and processes in place that kind of help you espouse and take on good culture, good value. So that's super important. And then finally, this is just the kind of egalitarian approach to everything, right? Which is, as a startup, you shouldn't get kind of drowned in this feeling of hierarchical structure and holier than thou attitude. Realize that everyone is on the same team. You're all striving to execute on something. No one is lesser than anyone else. And so, yeah, this is just kind of the hygiene factors on this stuff. But look, that was it from my end. And as I said, it was more of a kind of top level qualitative look at hardware scaling. And I hope that was helpful for some people.
That was great. Thank you so much, Vignesh. So many insights packed into such a small amount of time. I'm mindful that we're a little bit over, so we're going to keep the questions pretty minimal this time around, but we did have a great question about what your approach to prototyping is. Can you tell us a little bit about that?
Yeah, so look, I think with prototyping, that's part of the MVP game, right? And for me, it's really going to be around, I like taking commodity off the shelf sensors, commodity off the shelf chips. And I just love hacking that together, getting it out the door and showing how it works and selling the vision that way. So for me, I espouse the commodity versus bespoke argument from day one on the prototypes. But with prototypes, again, your purpose, you're pitching investors, you're convincing people to kind of back you on the journey and not necessarily selling product. So you shouldn't get kind of stuck in the mud about creating the most perfectly looking, beautiful piece of aesthetic engineering that you have. No, it just needs to educate and illustrate, right? Because I think VCs, Blackbird is a big fan of this, will love to play with what you have. And I know at the GD1 side, we love that. You give me a really hacked together MVP, I want to see it and I want to play with it. So that's the approach I take. But yeah, it is iterative, it is commoditized, and it is quite quick and dirty, to be fair. And that only comes with commodity engineering.
Couldn't agree more. I've also got a question around prototyping and bringing in an industrial design firm to kind of begin that next stage, with that ugly prototype you mentioned. Are there any things that you've seen go wrong at that stage of bringing in an industrial design firm, or like what founders and early hardware teams should be aware of?
Yeah, look, I think the industrial design thing is important. And I think it's a massive aspect of the experience, the UX, UI on the hardware side. I'm hesitant, and this is a personal bias, that I'm hesitant against getting outside industrial designers in, because they don't live and breathe your culture. They don't live and breathe your values. And for them, it's kind of a fly in, fly out type operating structure, right? That's not to say there aren't great contracting firms or consultants who do this for a living. There definitely are, but in the companies that I've worked with, I've seen the mixture of both, and I strongly prefer having people internal to the company on the industrial design who have that specific skill set, who have usability in mind, who have the user experience in mind, and are really able to kind of marry your vision, your goals with the user design.
Gotcha. Thank you. I think that's all the time we have with Vignesh this morning. But on behalf of Blackbird and everybody here on the call, thank you for sharing your advice. For our audience, I hope you'll join us next week for the final session of Giants Weekly this year, which will be a fireside chat with Blackbird co-founder and partner Rick Baker. And don't forget, we have opened up early applications for our new Giants community platform ahead of the launch in January. So if you're an aspiring or early stage founder, you can join to get one-on-one mentoring, connecting with fellow founders, and all of our best resources in the one place. So sign up through our website at blackbird.vc/giants. Great. Thanks.
Awesome. And just quickly add, guys, if you've got any questions, any follow-ups, feel free to send me an email. I realize I moved too fast past that page, but I'll share it with Melia. Yep. And I guess feel free to just kind of get in touch. I'm more than happy to have a conversation offline. Thanks, everyone. Thanks, Melia.
Thanks, everyone. Bye.